Okay. Well, this is like become an annual event. Every year at this time, I give a talk, and my talk usually very much like for entertainment, for fun. And so this is like a continuation what I've been doing for the last 3, 4 years. Okay, today I'm gonna talk about some numbers that maybe some of you heard of them, maybe not. Either way, it will not hurt you to remind you if you have seen them before. Okay, I think all of us know Fermat loss theorem. You know the Fermat, I mean the one, it's been unsolved for I don't know how many, 200, 300 years. And then Andrew Wiley, I think. Yeah, he solved it in 1994, 95, maybe at that time. And still, anyway, I'm not going to say much about it. Today, I'm going to talk about Fermat numbers. And these are kind of interesting numbers. So the first, I'm going to talk about Fermat numbers. And two, I'm going to talk about prime Fermat and non-prime Fermat. Okay, so we divide them into two, the numbers, the integers. Some of them will be prime, and let me remind you what we mean with a prime. Prime number is a whole number, is an integer where the factors are only one and itself. All of us know that. And if you have an integer that is not prime, all of us know then we can break it into what? As a product of prime numbers. We know that. Okay, so the first thing you're going to tell me, what is the Fermat numbers? They look like that. F for Fermat, index by n, where n bigger or equal 0, an integer. They look like 2 to the n plus 1. A number that you write it in this form, we call it Fermat number. The question, like let's take an example, let's let n equal 0. What do we get for Fn? This will be 2 to the 0 plus 1. That will be 3. So, is it 3 prime? So what we're going to call it? Prime Fermat prime or prime Fermat? What did I define it? Prime. Okay. All right, let's take n equal 1. What is F1? 2 to the 1 plus 1, which is equal 5. It's 5 prime. So what we're going to call it? Fermat prime or prime Fermat? I'm not going to change the definition now. Okay? What about n equal 2? What will be F2? 2 squared plus 1, and that will be 17. Is that prime? Prime Fermat. Okay? If you try n equal 3, what will be F3? 2q plus 1. Anybody has a, we need a calculator. Huh? 257. Is that prime? Is that prime? Okay, let's try F4. 2 to the 4 plus 1. And that will be 2 to the 16 plus 1. Your calculator will do 2 to the 16 or break down? Okay, let me write it down. 6, 5, 5, 2, 5, 3, 7. Is that the prime? It is prime. Okay. Try n equal 5. You're gonna get Fermat number, but it's gonna be what? It's not a prime. So look, from n from 0 to 4, we get what? Okay. Till this minute, these are the only known prime Fermat or Fermat prime. Till this minute, we have only how many? 1, 2, 3, 4. Okay? Till this minute, we only know 4 Fermat prime. 4 or 5? 5, because I start from 0. Okay, 5. So the question unanswered, and if somebody wanna, and maybe it's not laughing matter, anybody can attack that, but it's not easy to answer the question. How many Fermat prime do we have? Are they like finitely many or infinitely many? We don't know. We don't know. In fact, because we have these fancy machine and technology, it seems it's gonna be, somebody has to prove that these 5 are the only Fermat prime. Conjecture, but we don't have a proof for that. Because by now, we have a very fancy machine. If there is one after that, we should maybe, discover it by now. But we are not aware of any Fermat prime except these 5. Okay. Using machines for non-prime, for n bigger or equal 5, less or equal 32, when n is between 5 and 32. So what that means? You're gonna take 2 to the 5. That means 2 to the 32 plus 1. It's already known this will not be prime. So it's not Fermat prime. What we're gonna call it? Non-prime Fermat number. And this is established in 2014. Recent. Well, I mean, relatively speaking, 10 years ago. Somebody showed that when you let n between 5 and 32, and you start calculating Fermat numbers, none of them is a prime. Okay? So the question you're going to tell me, what about 2 to the 43 to I don't know, 43 plus 1? We know this is a Fermat number. But is it prime or what? Not the prime. I mean, I don't know if somebody did that, because you know my study showed that they tried till 2014. They were able to show that for all n bigger than 5, less than 32, all the numbers we get, none of them is a Fermat prime. Okay, in 2020, maybe before Corona or during Corona, maybe somebody has time to play around. And this is the largest non-prime Fermat. What do I mean? Largest non-prime Fermat. Meaning the number we're gonna get is gonna look like, you know, Fermat. Has to be a Fermat number, but non-prime meaning what? I can break it into product of prime numbers. This number is so huge, I cannot write it even. It's 2 to the power of 8-digit number here. I cannot remember it. Plus 1. Somebody show this number is given. I cannot remember it. But the number here is 8-digit number. As 8-digit. These show that this number is, of course, by definition, is Fermat number, but what? Is non-prime Fermat. Okay? All right. So you're going to ask me the mystery about Fermat. So far, we don't know how many are there. And is it really true? Only 5? Imagine only 5? Why? Only 5? And they are like consecutive. Look, n equals 0, n equal 1, n equal 2, n equal 3, n equal 4. It's not like there is a gap between the n. That will be maybe what's amazing for me, that they are consecutive. N equals 0, 1, 2, 3, 4. Until now, we don't know how many Fermat prime are there. We don't know. Maybe finite, maybe infinite. Even all indication, it seems that we only have that many, only 5 so far. Okay. Another thing amazing about Fermat number. Look at this. This is a prime. It's okay. But in general, here is some facts. For n bigger or equal to, the last digit n, Fn, this is fact, they prove it, is always 7. For n what? So if you calculate like 2 to the 7 plus 1, this is Fermat number. We don't know whether it's prime or non-prime. But what we know, when you calculate this number, the last digit should be what? 7.
But that one is non-prime because the n, we said between 5 and 32, all of them.
Yes, we know.
Okay,
yes, sorry, thank you. Because by this result here, we know that this will be non-prime. Between 5 and 32, all the numbers between them are not prime. Did somebody show that? Yes. But if you try this, the last digit is what? 7. For every n bigger or equal to 2. So like n3, we already calculated n3, this number. What is the last digit? Okay, we calculated n equal 2. Was n bigger or equal to? N2, 17. The last digit is 7. We calculated for n equal 4. 7. I mean, somebody proved that. It's not like conjecture. We know this is a fact. The last digit in Fermat number is always 7. Always. Oh, amazing, isn't it? That's like, you don't know why. Okay, let me tell you another fact. If you start with F0. Remember, what is F0 will be in our case? 3. And calculate, multiply it with F1. Multiply it with F2. Keep going, multiply. Fn minus 1. And add number 2, you're always going to get Fn. If you start from F0, you know what F0, multiply it with F1. We know how to calculate F1. F2, like imagine I want to do F7. So what I need? F0, F1, F2, up to where? F6, then I add what? That should give you F7. This is also, these are facts. When I mention fact, that means already somebody did that. We know that. They are true. What's amazing about Fermat numbers is this also. Take F n minus 1, square it, and add 1. That will give you also Fn. You can check that for us like what? Let's see, like when n equal 1. What is F1? 5. What is F0? 3. Minus 1. Square it. Plus 1. But this is true, has nothing to do with whether prime or not. The nth Fermat number is always Fn minus 1, take away minus 1 and square it, and then you add 1. Then you come up with the next Fermat number. So here is 1, and here is 1. Okay, here is another thing I thought this has to do. This is unknown, no answer to this question. What is no answer? Like, okay, let's take normal number, like 24. Can you write it as a product of a prime? What that will be? 2 cubed plus 3, right? Okay, what we call, here I have 2 to the power what? 3. This is, we call it not square 3. There is some power. And in the prime factorization, there is, okay, like 15. What's 15 equal to? 3. Is there any only to the power what? 1. This is, we call it what? Square 3. Okay? So what's meaning square 3? The number can be written as distinct prime, and all the powers to the what? 1. Not square 3 means what? at least one of the prime has to be to some power. Till this minute, this is not known. Is there Fn that is square that is not square free? So all the things, all the numbers we know, when you write them as a product of all the Fermat numbers, we know that can be written as what? Product of primes and all of them to the power 1, the one we know. Is still till this minute, we don't know. Look at the question. Is there Fn that is not square free? Oh, this is like magic. Why these numbers, you know, like always, when you try to factor them, you write the number as the product of the prime numbers and all these primes to the power 1. You don't have one of them repeated twice. Weird. Not just that. I'll give you the last one, and then I move to something else. I want to choose 2 squared minus 1 squared. So this is not known. No answer. What is that? 3. Is that Fermat prime?
Yeah.
Yes. 3 is where we get it to 3 from what?
F0.
I think n0. When n equals 0, we have 2 to the 1 plus 1. So this is Fermat prime or prime Fermat. Okay? Now here is the question that we no answer. Let me write it here. No, sorry. We have an answer to this, which is kind of interesting. If Q is prime and Q is not equal to there are no integers x comma y such that x to the q minus y to the q equal Fermat prime or prime Fermat. This is established. Look, if the prime is 2, I was able to get Fermat prime. Now, this is true, proof. If you spend your life and the life after, try to find 2 integers where the integer to the power 3 minus the integer to the power 3 give you what? Fermat? Forget it. You're wasting your life and the life after. Both. Because it's established you cannot do that. Right? This is amazing. And that's what number 2 always kind of unique. And we know 2 is what? Only even prime. Also unique. And even with Fermat prime, 2 is kind of interesting. Yeah. Okay, I forgot to mention something. I think I told you what is the last digit in a Fermat number? 7. Okay. Today I am 61. Add 6 plus 1. 7. And this is the last time in my lifetime where I add the digit of my age will equal to what? 7. That's it. For you. Huh? No, the last time I said. Okay, wishful thinking. Okay. Anyway, so this is make it or even more unique, 7 now for me. So I'm living my last year of achieving that the sum of the digits of my age equal 7.
What about 7 plus 0?
Huh?
7 plus 0, 70.
Oh, so I still have. Thank you.
Positive. You mean positive.
Okay. All right. So well, also this will be unique because this, if I stay here, that means I will retire because the retirement age in the AUS is at age 70. So that will be unique. Thank you. I missed that. I don't know why. So I still have some more. Okay. Also, there are 3 numbers this semester happened with me, kind of unique. Anybody want to discover the secret of these numbers?
They're the classes that you teach in.
Yeah, but look, I teach in room 109. Add the digit. 10. This. So I'm teaching in these rooms. Does not happen very often, right? If you add the digit, okay. So I think I still have time. Yeah. I'm gonna show you something even more fun. If you know this one, please don't spoil it for me. Nine 8001. This is an amazing number. You're gonna tell me why? How come this is amazing? Why this is an amazing number? Anybody heard of that? Why this is amazing number? If you heard about it, you can tell me, but don't talk about it till I finish. Okay. Of course, your calculator will not be able to find all the decimal. It will give you up to how many decimal the calculator you have. Yeah, approximation. If you try to do 1, let's try to do 1 over 998001 in decimal. This is amazing. Guess how this number gonna look like? First thing, how do you write 0 in a 3-digit? 0, 0, 0. How do you write 1 in a 3-digit? Okay, this number will be 0 in decimal. 1, 2, 3. Then, next one, 0, 0. What's the next one? What's the next one? What's the next one? You cannot keep going. 0, 51. 3 is going to be all the numbers between 0 and 999 except 998. So it will be this, 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 and keep going. you're gonna go to 900, the next one, 901, all the consecutive numbers, 3-digit, and keep going. You're gonna end up 996. What will be the next one? 997, 999. You skip what? 998. And then repeat. What do you think we're going to have after this? 0, 0, 0, 0, 0, 1, 0, 0, 2, and keep going. Forever. Repeated decimal. Repeated decimal. So this number becomes unique in the sense when you write it in decimal, we'll have all the numbers between 0 and what? 999, except what? 998. Your calculator will give you approximation. If you have a fancy machine without, approximation, because this has a proof. I can't tell you the proof of that. In discrete math, remember how every repeated decimal, we call it is rational number. So like you take this number, maybe multiply it with, I don't know, 100,000. And then, 100,000 x minus x. And, in theory, I see why. But this, and you simplify the fraction, you come up with that. So this number becomes unique. Okay, to make it easier for you, what is this number? Check. It's 999 squared. Is it? On your calculator, 99 squared is it 998001?
Yeah.
Okay, so look, 999, how many digits? 3. Repeated. Okay, let's take you and me, this number, 19801. I believe this is 1 over 99 squared. Is it? Do 99 squared. Will you come up with 9801? Yes. What do you think now this number is going to look like in decimal? 2-digit, starting from where? 0 till 99, and what you're going to skip? 98. So this number will be 0001, 2-digit, 02, 03, keep going, 90, 91, and then keep going, 97, 99. And then it's going to repeat itself, 00, 01, and so on. Okay, what you going to ask me now? What about 1 over 9, which is what? Maybe that's easy to check on your calculator. What do you think this will be? Numbers, how many digits? 1. And it's going to be 0, 0, 1, 2, 3, 4, 5, 6, 7, 9. And then 0, 1, 2, 3, and keep going. Is it? Should be. In fact, now I gave you that, so you know what to do. Even this is very huge number. 1 over 9999 squared. These 9, now the numbers involved with 9, kind of amazing. Okay, what do you think this will be? I don't know what the number is. You can I think it will be 1 over 999, 3 zeros, 1. Is it? Something like that. What do you think this number will look like in decimal? It's gonna be 4-digit. Start from where? Which number they gonna miss? Yeah, so this will be 0, 1, 2, 3, 4. Then 1, 2, 3, 4. And keep going. And then you have 9, 9, 9, 7. You skip what? 9, 9, 8. And then will be 9, 9, oh, 9, 9. Yeah. And then repeat. So you get the trick how you do these things. As I promised, I have other things to talk about, but I don't think I have enough time. I don't want to keep you long. This is for fun. I hope you're having fun. Okay. I want to do a trick. I told you, I think in the abstract, I'm going to be a magician now and show you some magic. This is how I'm going to end up my talk. Okay, here is the game. We have to understand the game, and then before we play. Okay. Choose. Anybody has like one piece of paper and a pen? Okay. 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 I can choose or you can choose. Choose any 4-digit number. All digits are distinct, but do not use 1. Go ahead, somebody name.
7, 6, 3, 4.
7,
6.
3, 4.
2, 3, 4, 5.
Just 1.
Oh, it's 1.
So here's the game. You choose a number, 4 distinct digits, but no 1. All right? Now you decide how many numbers you're gonna choose after this one. Like it has to be all the numbers below 4-digit, all distinct, but no number 3 in it. Look, the first number you gave me, distinct, and you are not allowed to use what? 1. In the second number, in whatever you want to give me, it should be what? Numbers, 4-digit, distinct, but no number 3. Let's start first slowly do it. How many numbers you want? You can go a million, but we're not going to spend here time adding a million numbers. Huh? 3. Give me 3. Oh, just a minute. No. Stop. So we decide on what? On 3. Right? Okay, here is the magic. You decided on 3. Okay. Okay. Now, give me the numbers. 3 numbers. Remember that you should not have what? Distinct, and you should not have 3 in it. Go ahead. One by one. Let's select. Let's start with the student. 9, 8, 2. No, 4 digit. 4. Okay. Another one. Yeah.
7614.
7,
614.
7, 6, 1, 4. Okay. There, I said it 3.
2, 3,
Huh?
sorry, 2, 1, 4, 5.
2, 1,
4, 5.
4, 5. Okay, now you gave me 3. I'm gonna add 3. For me, I have no restriction. You have restriction on you. You are not allowed to use 1. You are not allowed to use what? For me, I am 3. Okay. Let's have like. What did I do here? 2, I said, or 7? Okay. If you know it, don't spoil it for me, please. Okay. Calculator, add them. Huh?
Your number?
No, all of them.
Oh, okay.
This number, add this. Make sure more than one student do it to make sure we get it right. Add. Remember, this is 9824. Huh?
2,997.
37. Then 31.
631.
631. How did you come up with different? You're gonna add. What did you add?
I don't know the right number.
No, all of them. This.
Yeah.
All of them. Is that the number?
6761.
All of you?
Yes.
Okay, Isam, can you please show them the number I wrote? Okay. Again? Or one is enough? Okay. How many numbers you want? Okay. Now we can switch, by the way. What switch? Should not include 3 in the first one. And you should not include what? 1 in the numbers you gave me. Okay. So which number you want to start with? Remember, you are not allowed to use 3. Like 4, 2, 0. What? 7. Okay. Now you're gonna choose how many numbers? You tell me. 2? Okay. 2. All right.
Should not contain 1. You said that for the after.
Yeah. Should not contain 1. We switch the game. So I'm gonna write to you what you should come up with. Oh. Okay. What are the two numbers you're gonna give me? Remember, you should not have one. 9. Let's start. You always start with. You can, but let's start with 8. Then 5, 4, 3. Here 2, 4, 8. So what should I do now? I'm gonna add 2 more, but I'm free. I can't do anything. Okay, so I'm gonna have these numbers. Okay. Go ahead and add the numbers. Please more than one to make sure. So what you're gonna add? This, 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 and this. 2, 4, 205. Right? Okay, Assam.
It's impossible you get it correct this time. It's correct.
Okay, you want to know the secret?
Yes.
Okay. You're going to laugh. Here is how it works. In fact, all of you, I deceive you in a way. I let you think of 1 and 3, maybe. Like, why 1 and 3? This can be done without any restriction and without, you only need 4-digit number. Even they can be what? The same. They can be the same. So I did this just to distract your, thinking, because I know you might start thinking, why 1 and 3? So you don't pay attention to what I'm doing. And that's what magicians do, right? They distract you in something and you, okay, here's how it works. When you start with this number, and then I ask you how many numbers you need. Like here, how many numbers you need? You asked for 2. Okay? I know quickly I can look at this observation. Choose any number you want to explain it. Add a number where when you add the digit you get 9. So what you add to this number? 8, 6, 5. What you have? Is it? Has to do with the 9 again, right? So this will be like 10,000, but only missing what? 1. So when you gave me these, look, like this one, even to distract you, I gave this one. If you add this one to this one, what this will be? I already know it's going to be 2,000, but remove 20,000, but remove what? 1. Sorry, it's going to be what? 10,000. 10,000, right? Because look, is that number 10,000 minus 1? Okay, so when you give me this, I add the number I bought to add the digit to what? To 999. I know in my head they add up to 20,000. The same thing, what they add up to?
Only need the first number.
20,000, yes. And then I remove 2. 07. You see the same number, 24,205. Why were the 2 missing? Because look, this with this will give you 20,000 minus 1. This with this give you what? So when you tell me, like if you selected 5 numbers, I can quickly tell you it's going to be 54,202. And that's a nice trick, isn't it? I mean, you know, make you like wonder. But again, this trick is related to what? 9, 9. Is it clear, the idea? So the idea, I put the number, if you give me 4, I add up the numbers I select. So if like a number you selected with a number I select, I know they're gonna add up to 20,000 minus 1. And then the rest become history, you know. Okay, thank you for coming.